All right, let's talk about something that, unless you're an engineer, can be a real head-scratcher. Software maintenance. I mean, we get maintenance for our cars, right? Things rust, parts wear out. But software, it's just code. It doesn't have moving parts, so what gives? Why are we constantly maintaining it?
And that's the big question, isn't it? If the code was written correctly the first time, why does it feel like it's in this constant cycle of repairs and updates? It's a totally fair thing to ask, and the answer, well, it gets to the very heart of what software really is in the modern world.
Everyone loves the car analogy for this, but honestly, it kind of breaks down pretty quickly. With a car, you're fixing physical wear and tear. Software doesn't wear out. The real enemy for software is change. And here's the crucial difference. In your car, the parts are pretty self-contained, right? Changing the spark plugs isn't going to magically break the timing belt. But in software, oh, you better believe it can. A tiny change in one little corner can set off a chain reaction and cause something completely unrelated to just fall over. It's like changing your spark plugs and finding out your radio stopped working. In the software world, that kind of thing happens all the time.
So, to get a better handle on this, we can actually break maintenance down into 4 different types. Let's start with the 2 that are probably most familiar, the reactive ones. This is the stuff you do when something has already gone wrong.
First up, we've got corrective maintenance. This is pretty much what everyone pictures when they hear software maintenance. It's your classic bug fix. Something's broken, it's not doing what it's supposed to do, and a developer has to dive in and, correct the mistake in the code.
So, for example, let's say people are trying to log into your app with their social media account, and it just fails. The team digs in and they find the culprit, a bug, right there in your own app's code. So they fix it, push out an update, and boom, problem solved. That's corrective maintenance, plain and simple.
Okay, but here's where it gets interesting. Compare that to our second type, adaptive maintenance. It looks a lot like a bug fix on the surface, but the root cause is totally different. The problem isn't a mistake in your code. It's that the world around your code has changed.
Let's stick with that same login feature. One day, it's working perfectly. The next day, bam, no one can log in. The user sees the exact same error. But this time, when your team investigates, they find out the social media company changed something on their end. They updated their API. See the difference? Your code didn't have a bug. It's just that the rules of the game changed. You have to adapt your software to this new reality. So corrective is fixing your own mistakes. Adaptive is keeping up with everyone else's changes.
All right, so that's the reactive side of things. Now let's flip the coin and look at the proactive stuff. This isn't about fixing what's broken. This is about future-proofing and making things even better.
Next up is perfective maintenance, and honestly, this is where most of the time and money goes. Think of this as evolution. It's all about adding cool new features your users are begging for, tweaking existing ones to make them smoother, or even just cleaning house and getting rid of old features that nobody uses anymore. This is the work that keeps an app from getting stale.
Here's a perfect everyday example. You notice from user feedback that every single time someone logs in, the first thing they do is click away from their profile page to go to their activity feed. So, what do? You make a simple change. Now, when they log in, they land directly on the activity feed. The app wasn't broken before, right? But now it's just better, more intuitive. It's been perfected.
And that brings us to our 4th and final type, preventative maintenance. This is the real unsung hero. It's all the behind-the-scenes work that, when it's done right, you, the user, will never, ever notice. It's about looking into the future and fixing problems before they even become problems, like cleaning up messy code, beefing up security, or getting the system ready for way more traffic down the road.
Imagine your app suddenly goes viral. It gets a massive shout out and your traffic just explodes overnight. Without preventative work, what happens? Your servers crash, the app goes down, and you've just fumbled a huge opportunity. But because your team saw this as a possibility, they'd already done the work to make sure the system could scale up automatically. That invisible, proactive step is the difference between a massive success and a total disaster.
Okay, so we've got these 4 boxes: corrective, adaptive, perfective, preventative. But so what? Why does it even matter to label things this way? Well, it all comes down to one thing, really: money and strategy. If you don't understand these different types of work, you literally can't plan or budget for the real life of your software.
And this is where things get a little wild. We're not talking about a small percentage of the budget here. Depending on who you ask, maintenance can eat up anywhere from 67% to a whopping 90% of the total lifetime cost of a software project.
Think about that. The initial build, the thing you thought was the project, is literally just the tip of the iceberg.
And it's not like you can just say, okay, let's budget the average. This quote absolutely nails it. Trying to budget based on an average project is just asking for trouble. Every piece of software is unique. Its purpose, its complexity, all of that can make the real cost swing wildly.
To really see what I mean, let's look at two imaginary products. First, Product A. It's a social app for barbecue fans. Kind of flashy, built super fast by stitching together a bunch of third-party services from maps, logins, you name it. Then you have Product B. It's a super simple internal tool for a company to track employee rewards points. It's self-contained, no frills. Now, which one do you think is going to cost more to maintain over time?
Oh, it's Product A, and it's not even close. Every single time one of those third-party services it depends on decides to change something, Product A breaks. That's constant adaptive maintenance. Meanwhile, Product B is just humming along in its quiet, stable little corner. And that's the big lesson here. The cost of maintenance isn't about the initial build. It's about complexity and how many other systems you're tied to.
So, okay, we've established that maintenance is a huge, unavoidable, and super variable cost. So how on earth do you plan for it? You can't just cross your fingers and hope for the best. You need a real strategy, one that's tailored to your actual product.
It really boils down to asking 4 key questions. First, how mature is the software? Is it brand new and probably full of bugs, or is it old and stable and needs more future-proofing? Second, what's its purpose? Are you in a race to add new features, or is rock-solid stability the only thing that matters? Third, who's on your team? Do you have people who know this system inside and out? And finally, what are your constraints? What's the budget? Are there legal agreements about uptime you have to meet? All of this shapes your plan.
And when you do this right, the benefits are massive. We're not just talking about keeping the lights on. A smart maintenance plan actually lowers your costs over time, keeps your users happy, makes your system more secure, and gives you a stable foundation to build on so you can stay ahead of the competition. It stops being a cost and starts being a strategic investment.
Look, if there is one single thing to take away from all this, it's that we have to completely change how we think about software maintenance. It is not a tax you pay for writing bad code. It's the strategic, never-ending work of keeping a digital product alive and well in a world that refuses to stand still. So that leaves one final question for you to think about for any software you own or depend on. Is your budget and your plan built for the code you launched yesterday, or is it ready for the reality of tomorrow? Thanks for watching.